All right, so on this first one, these are the formulas that you're going to need in order to do well on the test. So with that being said, they will be given to you, but you do need to know when they're being used. So these are the different formulas. So just make sure you have them kind of memorized, but again, you can use them. They'll be given to you. So continuously is going to be this one. A lot of y'all have been asking me what E is, and that is really important. E is like this number that is 2.718. It's kind of like pi, just a little bit, but it's 2.718. All right. On this next one, it says write all the possible expressions for x determined by the relationship between the exponential and logarithmic form of the equation. So on your paper, you have 4 to the x equals 64. So the different ways to write this out is, first, if we were trying to go into log form, we would go from 4 over to 64 up to x. This is the circle of life. Okay? Yeah. So we're going to say log of base 4 of 64 equals x. If I were to put this into my calculator, I would use change of base form, which would be log of 64 divided by log of 4. And if we put that into our calculator, we would get x equals 3. And if that's the case, then we could also write this as ln of 64 divided by ln of 4. And that would also give us 3. All right, so on this next one, this is using compound interest. So this is going to be using this formula. Okay. And semi-annually is when n equals 2. Monthly is n equals 12, quarterly is n equals 4, weekly is n equals 52, and don't worry about monthly again. So it says that she wants to save up to $1 million. So $1 million is going to be that final amount. 2% is going to be my rate. So for those of you who are visual, 2% is going to be this rate. My final amount is this. And my n is going to be this. Now, time is going to come from the fact that they tell us that they want it in 50 years. So when I set this up, I'm going to do 1 million. 6 zeros. There we go. Boom. Equals P, which is what I'm trying to find. 1 plus my rate, which is 0.02%, divided by 2, which is my n, raised to the 2 times 50 years. Okay, so what we're going to do is we're going to use our calculator, and we're going to put this mess into our calculator. So we're going to say 0.02 divided by 2 plus 1, and we're going to raise that to the 2 times 50 power. This is 2.7048. So this is P times 2.0748 equals 1 million. So now I still want P by itself because I want to figure out how much money I have to save up in order to have $1 million by the time I turn 50. So I'm going to take 1 million. And I'm going to divide it by 2.074. I'm sorry. I wrote that number wrong. 7048. So that's going to give me 369,713. 0.10. Okay, so this number should be 7048. My bad. Okay. Now, you can repeat this process for each one of these, and the only thing that you're going to change is the n values. But essentially what you would do is just plug in and still solve. I'm not going to do that in this video just because we've got other problems to get through, but you could do that for each one of these. All right, so on 3, it says rewrite the function so that you can solve for m. So this is your equation right here. Don't get caught up in the fact that this says b of m. Just rewrite it as b. That's okay, because at the end of the day, all you're doing is solving for m. So first thing you're going to do is divide by 50 on both sides. So this is going to give me b divided by 50 equals 16 raised to the m divided by 12. I'm going to put this in log form. So I'm going to start at my base, go to the outside, finish at the exponent. So this is going to be log of 16 of b divided by 50 equals m divided by 12. Now, in order for m to get by itself, I'm going to multiply by 12 on both sides. So that's going to be m equals 12 times log of 16 of b divided by 50. And that would be my answer. Now, I could write this another way. I could say m equals log of 16 of b divided by 50 raised to the 12th power. It just kind of depends on the test or the interim that you would take. They're both the same thing because we know our power rule means that we can take this number out front and put it as our exponent. On part B, it says, in how many months will the number of brain connections double in an infant's brain? So that means that we're going to go from 50 to 100. So we're going to actually use this formula right here, and we're going to plug in 100 for B. So that's going to be 100 divided by 50, which 100 divided by 50 is going to give me 2. So now I'm going to plug this in my calculator. I'm going to say log of 2 divided by log of 16. So that's going to give me log of 2 divided by log of 16. And I'm going to multiply that by 12. The reason why I'm multiplying it by 12 is because that 12 is on the outside in the front. And that's going to give me 3 months as my answer for B. On this one, Sheila just graduated from college and started her first job 1 month ago. As a graduation gift, her parents gave her a 2020 red electric Prius, fully loaded, for $32,500. So $32,500 is my initial cost of the car. Okay. She intends to keep the car for the next 5 years. The equation which models this is this. What does that 0.79 represent? That is the rate of depreciation. Where the value of the car goes down. T is going to be the number of years. Cool? So if I have this equation, I'm going to rewrite it to solve for P. Okay, so I want to write this in exponential form, and the equation that I pulled this from is this one right here. I'm going to write this in exponential form. I'm going to start at my base, go to the outside, finish here. So 0.79 raised to the t power equals p divided by 32,500. I'm going to multiply by 32,500 on both sides so that I can get p by itself. So that's going to give me 32,500 times 0.79 raised to the t power, and that's going to equal p. On part C, it says calculate it if she keeps it for 5 years. So all I'm going to do is plug in a 5 into the equation. I'm going to come into my calculator and say 32,500 parentheses 0.79 raised to the 5th power. I'm going to hit enter. That's going to give me 10,000.43. On number 5, it says write a function q for which the output increases by 35% every time and the input increases by 1. So we're going to use this formula, the growth and decay for these. So this is increasing, so we're going to use the growth formula. So we're going to say 1 plus 0.35 raised to the t power. And that's what q is going to equal. Okay. For R on 5B, it's going to decrease by 35%. So R is going to equal 1 minus 0.35 raised to the t power. So this could be written out as 1.35 raised to the t, and this can be written out as 0.65 raised to the t. It just kind of depends on what your test says or your interim. Number 6, what do each one of these represents? Well, if you read this, it says the pollen count can be represented as this function. Okay, so the initial pollen count is going to be this 44. Initial pollen count. which I don't know if you know this, but like over 30 is like really bad, I think. 12 is going to be the rate. W divided by 4 is going to be the months, because we know that 4 weeks are in a month. So that's going to tell us the number of months. This says at what interval does the pollen count become 12 times higher? So what you're going to do is you're going to take 44 and multiply by 12, and that's going to give me 528. So that's going to give me what the pollen count is on the left-hand side. You're going to set that equal to 44. And now we're going to solve. So the first thing we're going to do is going to divide by 44 on both sides. And that's going to give me 12 to the W divided by 4. This is going to give me 12. Now if I write this out in log form, I'm going to go from base to the outside to the exponent. So this is going to be log of 12 equals W divided by 4. If I plug log of 12 into my calculator, I'm going to get 1. And if I solve for W, I'm going to get W equals 4. On 7 and 8, says the koala bear population in Australia has been decreasing at the same rate each year since 1995. So 180,000 represents the initial population of koala bears. Okay. 0.929 is the rate that they are decreasing. Okay. What is a percentage decrease of the population per year? So when we talk about decreasing, we've got this formula. So we're going to take 1 minus 0.929, which is the rate they gave us, and that's going to give us 0.071. Now if we change that into a percentage, because that's what it asks us to do, we're going to have 7.1% decrease per year. On C, it says calculate the population in 2010. Well, if we start from 1995 and go to 2010, that's 15 years. So we're going to take the original equation, which they give up here, so 180,000, and we're going to raise it to the 15th power. So when we plug that into our calculator, we're going to have 180,000 times 0.929. We're going to raise that to the 15th power. And that's going to give us 59,635 koala bears. So in 15 years, they're going to die out to have only like 60,000, right? And then it says in how many years will the koala bear population reach the size of 100? So we're going to set 100 equal to this equation. Oh, whoops. And we're going to solve for t. So the first thing we're going to do is divide by 180,000 on both sides. Okay, so I'm going to put this on another page. So it's going to be 100 equals 180,000. So I'm going to divide by 180,000 on both sides. Sorry for my handwriting. And so if I plug 100 divided by 180,000 onto my calculator, that's too many. Yep. That's going to give me this number, which this e to the negative 4, that's taking the decimal place and moving it 4 times over. So that's really just going to be 0.00055. And that equals 0.929 raised to the t power. Then I'm going to put this into log form. So I'm going to start from the base, go to the outside, and end up at the exponent. So log of 0.929 of 0.00055 equals t. If I plug this into my calculator, I'm going to get log of 0.00055 divided by log of 0.929. And that's going to tell me that it's going to take 101.9 years for those koalas to get to 100.